Okay, so what we're going to do in this video, I've marked it as Market Equilibrium Worksheet 1, and basically we're going to start off with a bit of revision on demand and a bit of revision on supply, and then we shall go into Market Equilibrium. And this is rather quick, they move quickly through the stuff, so make sure to watch all the videos on this one, worksheet 2, 3 and 4. Okay, so the first one is, the linear demand function for smartphones is given as QD equals A minus BP. Explain what this shows, right? Well, A equals autonomous demand. It is where the function crosses the Q axis and the quantity demanded where price is 0. The B value, and I prefer to have this as a plus B, but that's my mathematical tendency. The B value is the slope of the demand curve. It's how much quantity demanded changes when price changes by 1. And so a change in A is a shift of the demand curve, and a change in B is a change in its slope. Okay? Now, on to the next thing. Okay, using a fully labeled diagram, and actually that's not a bad point just to make sure that we're labeling everything. This is the price axis, this is the quantity axis, and then I will also write demand curve, okay, up the top. So basically I just want to make sure that you label everything. All right, now it says what I'm gonna have here is a sheet of paper, so it's QD equals 800 minus 25p. So I'm going to use this extra writing here. So QD equals 800 minus 25p, and it asks us to draw the demand curve. So basically what we're saying here is, well, look, first of all, I've said this ad infinitum in a number of other videos, this A here, this autonomous level of demand, is where P equals 0, QD equals 800. So that's one point that we have. And the next one is, I'm going to set quantity demanded equal to 0. So we've got 800 equals 0 as quantity demanded equals 800 minus 25p. I'm going to bring the minus 25p over. That becomes a plus 25p. And then I'm going to divide both sides by 25. Then what we do is we take out our calculator. 800 divided by 25 equals 32. So these cancel. I have P equals 32. So what we have now are 2 points. P equals 32. Quantity demanded equals 0. So I've got my graph all drawn here, just moving it so you can see. Okay, and the first one is P0, quantity is 800, and the next one is 32, and the quantity is 0. So we join these dots here, okay, and it's that simple. There's our demand curve. No problem whatsoever, I would hope. All we did was we found 2 points that were on the curve and then just plotted them there. Okay, I hope that's okay at this stage. Just a quick bit of revision on the demand. All right, now looking at this question. All right, and we've already answered this in another one, but I'm happy to do it again. So I'll use the space that's available to me. So A equals 600, okay, 600. So what we've got here now is QD at the moment equals 600, I'm going to say plus BP, right? Now, another thing that we can do, and this is different to the other video that I've done the exact same question in, is that we can just substitute something in that we already know. All right, so we've already used this point. So what happens if we put this point in here? So what we get is, we know that at a price of 15, quantity demanded is 0. So it goes 0 equals 600 plus B times 15. Okay, so 0 equals 600 plus 15b. I'm going to bring the 15b over, becomes minus 15b equals 600. Divide both sides by minus 15. And again, and I think, I don't even want to guess, 15. And I was right, it's 40. But don't forget, it's minus 40. So the demand function here is QD equals the number on its own, which is 600 minus 40p. Okay, that's what that equals there. I hope that makes sense. I did it a different way in the other video on the demand note if you have any issues. Suppose the daily demand for organic chicken at a supermarket is given by the function QD equals 420 minus 12p. QD equals 420 minus 12p. Calculate the daily revenue for the sale of organic chicken if the price is 8 kilograms. Well, as we've said, revenue equals price times quantity. So we need to find the quantity. So QD equals 420 minus 12, the price is 8. QD equals 420 minus 96. QD equals, and I'm going to go 420 minus 96 equals 324. 324. Okay. Now, the next one here is that we go the revenue equals the price, which is 8, times the quantity, which is 324. Bring my calculator back in, times 8 equals 2592. So the revenue in terms of dollars, 2592. Okay. And there's nothing about thousands, so we're all good here. Okay, the next one, okay, I hope you can see this. This is 8, 7, 50, and 60. It says, with reference to the diagram below, calculate the change in the value of sales revenue if the firm raises its price from 7 to 8 and comment on your findings. So, okay, again, so the revenue 1 equals 7 times 60, okay, which is 420. Revenue 2 is price times quantity, like this was price times quantity, which is 8 times 50, which is 400. And then the change, which is that triangle, means change in revenue equals Rev 2 minus Rev 1, which equals, sorry, that's 400, excuse me. 400 minus 420 equals minus 20. Okay, so there's a drop in revenue of $20 from the increase in price. Now, onto the supply part. Again, just a bit of revision, hoping that all this will make sense. Okay, so the supply curve for a particular product is given by QS equals minus 800 plus 20p. Calculate the lowest price that would create an ability and willingness for firms to supply. So basically what we're asked to find here is the price where quantity supplied is 0. So what we actually have to do is, I tend to write out the function every time. Just, I don't know why, I think it settles my mind or whatever. So I find it helpful. And if we set this equal to 0, we've got minus 800 plus 20p. I'm going to bring the minus 800 over, and I get 800 equals 20p. I'm going to divide both sides by 20, and I'm not going to even think of doing this in my head. Not that it's a difficult sum. Don't know what's going on here. Yeah, okay, just that when you are in an exam, you will be tired, okay? And that is when you can make simple mistakes. So P equals 40 or $40, okay? That's, anything above that is when, that's 5 by 8, 40, yeah. Anything above that is when supply starts to occur, okay? So the supply curve for a certain product is given by the function QS equals 300 plus 10p. Now the fact that that's not a minus is not necessarily indicative of reality, because what that's saying is at a price of 0, the firm would be willing to give away 300 units. That really isn't true. Price has to at least rise above 0 in order for the firm to be in a position to cover its costs, but it doesn't matter. If technological progress enables 200 more units to be produced at each price level, or at each price, that shouldn't be price level, that means something else in economics, show the new linear function of the supply curve. Well, all this is, right, it's QS equals 300 plus 10p, and all of that plus 200. And the reason is, okay, because what we're saying is the curve is shifting outwards. There's been technological progress which causes the curve to shift outwards. So what we then do now is just add on 200 to every single price, and that's what this function tells us in the original state, that we can work out whatever quantity is supplied is at each price because we plug it in here. Now what we're saying is whatever we get, we need to add on another 200. So all the new function is QS equals 500 plus 10p. It's an outward shift. It's not a change in the slope. Okay, now plot the supply curve with the following linear function. So again, I'm going to go back, and it's QS equals minus 100 plus 10p. Okay, so I'm just going to make sure you can kind of see some of, well, I suppose that, right? And I'll push this up here for a second. So we've got QS equals minus 100 plus 10p. Now what I tend to do is I tend to find where it crosses the p-axis, and that means you set QS equal to 0, the quantity equal to 0, which is minus 100 plus 10p, and that 0 equals all of that, right? Then what we do is, and I will move this up now so you can see better, I'll bring the minus 100 over and I get 100 equals 10p. I'm going to divide both sides by 10 and I get 10 equals p. So what we're saying here is at a price of 10, quantity supplied equals 0. So that's where it cuts the p-axis, right? So this is the start of it here, is there. That's where it starts in the positive domain, in the positive realm. And then what I'm going to do is I'm just going to choose another one, why not 30? So p equals 30, okay? So I get qs equals minus 100 plus 10 times 30. qs equals minus 100 plus 300. qs equals 200. So at a price equal to 30, we have quantity supplied equals 200. I hope I've labeled everything here out here, and I haven't. So I need to add another 0 along here. Okay, so what we're saying is plus 10p, 10 times 30 is 300. Yeah, absolutely perfect, okay? So what we're saying here is that at a price of 30, it's 200, which is there, and I hope we can see that, and I think we can. Okay, so what I need to do now is get out my ruler and join these dots, all right? And take my time doing this, make it nice and neat, and I have this is my supply curve here, okay? And I hope that makes sense. Again, just plugging in numbers and, seeing what comes out, okay? Now, onto this, okay? Just want to make sure to adjust this so you can see it. All right, so the question reads, explain which of the following supply curves would be flatter. QS1 equals 40 plus 4p, or QS2 equals 40 plus 8p. Okay, so what we're saying is they both have the same C value. Ideally, most likely we would expect these to be negative, just to be clear. But that's not important because we're asking about flatter or steeper. That means we're talking about slope. And when we're talking about slope, we want to discuss the number before the P. And we said in the demand video and in other supply videos as well, that it's the number before P. The bigger it is, the flatter it is, whether demand or supply. Okay, so the greater the number before P, the flatter the curve. So therefore QS2, this one here, is the flatter of the two curves simply because it has a bigger P value. For every $1 increase in price, QS2, the quantity supplied by whatever firm 2 or whatever this is referring to, changes by 8 times that change in price. Here we said it was $1, but now it's 8. So for every $1 change, quantity supplied will change by 8, whereas it only changes by 4 times in QS1. And that's what we're saying. The bigger the number before P, the flatter the curve, be it demand or supply. The smaller the number before P, the steeper the curve, be it demand or supply. And be it demand or supply, the number before P is the slope. Okay, now on to this question. Study the supply curve below and calculate its linear function. Okay, well what we've got here is, we've got QS equals C plus DP, right? Now, there are a few things that we can do here. For whatever reason, I just feel like finding the slope first, okay? Now, the slope is given by QS2 minus QS1 which is over P2 minus P1. So I'm going to say here, QS2 is a price of 40 and 200, and QS1 is 30 and 0, okay? So I'm going to say that the price has risen. So P1 is going to be 30 here. I'm going to write this down here, 30, and then a minus in front of that. And then the quantity is 0, I'm going to minus in front of that. And then P2 is 40, and it's 200, okay? So what essentially we get is 200 over 10, which equals 20, as long as I haven't done anything stupid there, all right? So what we know now is we've got QS equals C plus 20P. Now, we only need to find out one thing in this. I know we've got a QS, I know we've got a P, but we don't know C, and we can plug in these numbers here. So any number will be fine, but I'm saying at a price of 50, 400 is supplied. So I can go 400 equals C plus 20 times 50, okay? So 400 equals C plus 2, 5. That's 1,000. Okay, so I bring the 1,000 over, I get 1,000, sorry, minus 1,000 plus 400 equals C, minus 600 equals C. So the quantity supplied equals minus 600 plus 20p. And that's the answer to that question there. Okay, and if we plug in anything, 30 into P, that'll be 20 times 30, which is 600, minus 600 is 0. 40, which is 800, minus 600 is 200. All of these are working out. Okay, so that's the next thing. So that's just a quick revision of supply. It's not much use. Now, I kind of don't like this question, but I'm going to answer it anyway because I've asked it, so I'll leave it in. But calculate the value of the total area of excess supply in the diagram below if the price is 15. Right, now if the price is 15, you go out to the demand curve, you touch the demand curve, you go down, and there's 15 units bought. At a price of 15, you go out to the supply curve, you touch the supply curve and down, and there's 25 units bought. So what they mean by the area is this triangle here, okay, all of that, right? Well, how do you find the area of a triangle? Well, it's half the base times the perpendicular height, and I suppose I should have written this here. Half the base times height. Right, well, the perpendicular height is 5, okay, because it's from 10 to 15 here, which is 5, okay, and then the width is 10. But I'll write it out. So it's 1/2 multiplied by the base. I'm going to call this the base, which is 25 minus 15, 25 minus 15, times the height, which is 15 minus 10, 15 minus 10, okay, and that's 1/2 times 10 times 5. And I'm going to go 1/2 by 10 is 5 times 5, which equals 25 units squared. Okay, and that's that. I don't think that's necessarily a great way to do it, but you know, whatever. It doesn't matter. Okay, and then I think the same. Yeah, the total area of excess demand at a price of 10. Okay, well, at a price of 10, you go out. This is the supply. You go down. You touch that. That's 30, and then you go out to the demand, and that's 50. Okay, so what they're saying here is this whole area here. Don't worry too much about these questions. It becomes more important when we talk about consumer and producer service. Okay, well, it's half the base. Okay, half. The base now is 50 minus 30. 50 minus 30, which is the distance from here to here, times the height, which is 20 minus 10. 20 minus 10, which is 1/2, which is 20 times 10, which is half by 20 is 10 times 10, which equals 100 units squared. Okay, now on to the next question. Okay, the table below shows the demand and supply schedules for a product. A fall in production cost increases supply by 20 units at all prices. Calculate the new equilibrium price. So what I've done here, because there's an outward shift, that means that the slope hasn't changed. And we're not worried about slope or intercept here. But what we're saying is that every single price, 20 units is going to be added on. So at a price of 5 instead of 60, well, we have to add 20, so now we're on to 80. At a price of 70, or a price of 6, instead of 70, we have to add 20. So that means now we're on to 90. And if we look here, what's the definition of equilibrium? A situation where quantity demanded equals quantity supplied and there's no tendency for price to change. So the new equilibrium price is where the new quantity supplied equals the quantity demanded, and that's 90 equals 90, and that happens at a price of 6. So what we're saying is equilibrium price equals, that's in dollars, $6, okay, because at that price 90 equals 90, quantity demanded equals quantity supplied, and we had to add 20 units because there's an outward shift. Okay, calculate the equilibrium price and quantity if the demand function is given by QD equals 600 minus 3P and supply function is given by QS equals minus 100 plus 2P. Now, in equilibrium, and I'll just shorten this, in EQ, quantity supplied equals quantity demanded. Quantity supplied is minus 100 plus 2P, and that equals the quantity demanded, which is 600 minus 3P. Now, if I bring over the minus 3p here and bring over the minus 100 here, I have 2p, that stays there, plus this 3p, bring it over, change its sign, equals 600 plus 100. So what we have is 5p equals 700. Divide both sides by the number before, the letter we're trying to find. The letter we're trying to find is p. The number before p is 5. So it's, so we calculate that, 700 divided by 5 equals 140. P equals 140. Now calculate the equilibrium price and quantity. Right now we have the price. If I plug this into either quantity demanded or quantity supplied, I should get the same equilibrium quantity. So I'm going to go into quantity demanded minus 3 times 140. QD equals 600 minus 140 by 3 equals minus 420. Okay, QD equals, now I think that's what, 180, but 600 minus answer equals 180. QD equals 180. Okay, so what I'm saying to you is that the equilibrium quantity is 180 and the equilibrium price is 140. If we've worked out this correct equilibrium price, therefore we should be able to put it into this, and now we don't have to do this, but it's a good idea to check, is that if we go QS equals minus 100 plus 2 times 140, QS equals minus 100 plus 280, QS equals 180 units. Okay, and I'll put units here and units here. They are both the same. The market is in equilibrium. Price has changed in order to bring the market into equilibrium. Okay, now somewhat nearly done. Okay, let's make sure you can see, and you can see now. Okay, suppose the demand function for a product is given by QD equals 80 minus 2p, while the supply is expressed by QS equals 2. Plot the demand and supply function and supply curves and identify the equilibrium price and equilibrium quantity. Okay, right. Well, again, what we're going to do is, so I'm going to do the demand one, which is 80 minus 2p. Okay, so what we've got here is QD equals 80 minus 2p. Okay, so the first one is at a p equals 0, quantity demanded equals 80. Not even going to explain why, it's just, well, I will, I suppose, but it's the number on its own. Now, 0, I'm going to put in 0 for quantity equals 80 minus 2p. Bring the minus 2p over, becomes plus 2p equals 80. Divide both sides by the number before the letter we're trying to find. The letter we're trying to find is p. The number before p is 2, and we get p is 40. So what we're saying here is p equals 40, QD equals 0. Now, so let me get my pencil out. So P0 is 80. Oh my God. Is that right? It is. I will not be doing this though, so I'm going to use a different one here now. Okay, so I'm going to go up in 20s here. Okay, I'm going to 20, 40, 60, 80, 100. So we've got P is 0, QD is 80, and then P is 40, QD is 0. Okay, so we've got this, and this is important to try and draw this as accurate as possible. There's the demand curve. Now, a little, not tricky, I wouldn't like to say tricky, but just a little bit different. Don't forget now, the QS is 2P. Okay, so there's no number on its own, there's no C value. So if I go QS equals 2P, if I set P equal to 0, then I get QS equals 2 times 0, QS equals 0. So then QS equals 0. So what that actually means is that this point here is on it. Okay, now if I set P equal to, let's say, 20, and I'm kind of cheating here because I see it. So if I say P equals 20, then QS equals 2P. QS, I do apologize. Again, you know I have a tendency to do that, equals 2 times 20. QS equals 40. So when P equals 20, QS equals 40. So then what I do is I go up here and, oh, wouldn't you have it? It seems to be at the equilibrium point. So what I do now is I join these dots and I get the S, and this point here is equilibrium, and this is QEQ, and this here going all across is PEQ, okay? And that's that. Now, plot the demand and identify the equilibrium price and equilibrium quantity. Okay, sure, we might as well write it down. PEQ equals $20, and then QEQ equals 40 units. Okay, use your graph from this question here to calculate the value of consumer surplus. Now, what consumer surplus, listen very carefully, is the area below the demand curve and above the price. Okay, above the equilibrium price. So we have an equilibrium price of 20. Okay, we have an equilibrium price of 20. And now what we have here is this whole area in red here is what's called consumer surplus. CS, consumer surplus, okay? So, well, how do we calculate the area of a triangle? Well, it's half the base times the height. So it's half times, I'm going to call this the base here, which is 40 minus 20, because it's that long, which is 20, times the height, which is 40, So I get 1/2 equals 20 times 40. 1/2 times 20, God, I'm so annoying how I do this. I do apologize again. 1/2 times 20 is 10 times 40, which equals 400. And now consumer surplus is measured in dollars, okay? It's the area below the demand curve and above the price. There were people that were willing to pay this price, but they only had to pay the market price, so they're that much better off, okay? It's the difference between what the consumer was willing to pay and what the consumer actually had to pay. Now, just moving everything here at the one time. Okay, calculate the quantity of excess demand, the quantity of excess demand, not the area of excess demand at a price of 10. Well, if we go across here, and I shall use my blue pen, at a price of 10, okay, so the amount supplied at a price of 10. Now, did it ask the area or the quantity? Yeah. Okay, that's a more sensible question. Okay, well, it's 60 minus 20. So excess demand, okay. Okay, what that equals is 60 minus 20 equals 40 units. Okay, and that's at a price of 10. Okay, there'd be no excess demand at the equilibrium price because quantity demanded equals quantity supplied. Now, I'm coming up to 30 minutes. I'm almost done. Just this one last thing here. Calculate the quantity of excess supply at a price of 30, and I think it's the opposite, is it? And it is, but I'll do it anyway. Okay, so at a price of 30, the price is above the equilibrium price, the market clearing price. So what that means is supply is going to be greater than demand. So we go out to the demand curve, which is here, and then we touch down and we get this. Okay, so 20 is demanded, but the supply is here, which is 60. So the excess supply equals 60 minus 20, which equals 40 units. And I just want to make sure I haven't done anything stupid. I've read that correctly. Yes, that's 20 and that's 60. Absolutely. Okay. And that is the end of that worksheet.